Hello wonderful people, let me talk about complement system. Complement system is a complex subject on many students, but at the end of this video, I'm going to make it like piece of cake. So complement system is cascade of many proteins work together to destroy antigen or pathogen which invade our body. So this complement system is called complement system because it complements your immune system. To mean that antigen alive in our body, now antibody come make antigen antibody complex, but this antibody is unable to destroy this antigen. Now antibody activate complement system. Now the series of the protein come boom now to destroy that complex of antigen antibody complex. To mean that these complement system are very important in immunology to help to destroy pathogens which are alive in our body. Usually this complement system is made of the protein. These protein are synthesized in the liver, to mean that when you have liver damage, you are going to have to be immunocompromised. So these proteins are in the complement system are arranged from C1 to C9. What this C means as we are having F for family, also you have C for complement. To mean that when we say protein 1 in complement system, it is C1. To mean complement 1, complement 2 up to complement 9. So to mean that in this complement system, we are having 9 proteins which are helping us to destroy antigen in our body. So to mean that our complement system, they act as a bridge of innate and adaptive immunity. So we will see that there is many pathways in this complement system. There are 3 pathways, as you are seeing here. There is classical pathway, there is mannose binding lectin pathways, and there is alternative pathway. At the end of this video, all of this sheet, they are going to be very easy for you. Stay with me. Let we start. We are going to do this complement system in the way of mnemonic. Every single slide there is a mnemonic which is easy for you to understand this complement system. Stay tuned. So this complement system, they are having several functions in our body. Like I have a mnemonic for you, A, B, C, D. Means the importance of the complement system, number 1 is agglutination. Here is bacteria, all of these are pathogens. Means complement system are going to make to combine it together so that immune system can come and break down as once. So to mean that they condense antigen to pathogens together so that immune system can destroy at the once. So A for agglutination, B for bacteria opsonization. Opsonization means this complement system come and put sign on this pathogen so that this pathogen is going to be very easy or is going to be very determinable by our immune system. Means this sign or this pathogen, immune system is able to recognize this pathogen because of this sign. This process called bacteria opsonization. Other is C for chemotaxis. D is for direct cell killing. So finally, neutralization of viral toxins and release of histamine from the master cell and basophils. So here there are 6 importance of complement system activation. So number 1, A for agglutination, B for bacteria opsonization, C for chemotaxis, and D for direct killing. All of these are importance of complement system. So complement system usually, as we have seen, that they are having 3 pathways. Number 1 is classical pathway. Number 2 is lectin pathway or mannose binding pathway, and another is alternative pathway. All of 3 pathways, they form C3 convertase, means it is protein 3 which is complement 3 convertase. All of them, they form C5 convertase, and finally they form what we call membrane attack complex, which will come and make pollens on the bacteria or pathogens, and they destroy automatically cell lysis. So this one is it is like a bullet in the gun. They go and shoot pathogen, and now pathogen is no longer causing harm to our body. So it seems like it is very difficult to memorize those numbers, but stay with me. I'm going to show you the mnemonic. So the pathway number 1 is classical pathway. In this classical pathway, you should understand how it's activated and how we are going to form C3 convertase and how we are going to form C5 convertase, and also termination, we are going to formation of membrane attack complex. So without further delay, let we start. Usually, as we have seen here, you should memorize activation of this one of the 3 pathways. Means those pathways, as there are 3, they activated one by one according to the characteristics of the antigen. Suppose that the antigen come and they form antigen-antibody complex. Now, classical pathway is the one which is going to be activated. So, let me start. Now, antigen-antibody complex means this antigen, they form antigen-antibody complex. So, they will come and activate C1. Now, C1 will activate C4 and C2. This C4 and C2 activated, they are going to form what we call C3 convertase. Finally, they form C3b activation. Now C3b and C4b, C2b, all of them together, they're going to be called C5 convertase. This C5 convertase are going to form what we call MAC, membrane attack complex. So this one is the one which is going to come and make a pollens on this bacteria, and now self-killing or direct killing of this bacteria. So it seems to be complicated, but let me easy life by this mnemonic. You should count with me. 1, 4, 2, 3, 5, 6, 7, 8, 9. So this is the way those protein cascade are going to intervene in this classical complement pathway. To mean that complement number 1 is the one which come first. By help of enzyme called C1 esterase, they are going to be activated. Now, after being activated, they are going to activate complement 4, which is another protein. This complement 4 will give, in form of activated form, they go C4b and C4a. C4a will be eliminated from the cascade. Now C2b also is going to be activated by this 4b activated, which are going to form C2b activated form of C2. Now the 2 are going to be called C3 convertase. This is an enzyme which will convert another protein, which is C3, into C3b and C3a. C3a will leave this pathway, where we're going to continue with only C3b. Now C3b together with these 2, C4b, C2b activated one, will form what we call C5 convertase. Means C4b, C2b, C3b, all of these 3 will be called C5 convertase. This is enzyme which will convert another protein called C5 into C5b and C5a. Now C5 will recruit 6, 7, 8, 9. All of them, they will form what we call membrane attack complex, which will attack this bacteria, and automatically there is direct killing of this pathogen. So this is what's all about the classic complement pathway. So it is not complicated. It's to take 1, 4, 2. This one will activate 4 and 2. Now this one will be C3 convertase. This is the enzyme which will convert C3 into C3a and C3b. Now this C3b together with C4ab and C2b together with this C3b, they are going to form what we call C5 convertase. This C5 convertase, they are going to activate C5 into C5A and C5B. C5B, we're going to continue in the pathway. Now C5B will recruit another complement protein 6, 7, 8, and 9. So by helping by 1, 4, 2, 3, 5, 6, 7, 8, 9, you can summarize this classic pathway in short. This is very, very easy. Take time and review. You should keep in mind that to activate this classical complement pathway, you should have antigen antibody complex. So let's have a look on the steps. So in the steps, these classical pathways, step number 1 is recognition. Means that there is C1 protein will be activated by binding with antigen antibody complex. So this C1 which is activated, they are going to activate C4 into C4A. This one will go in inflammatory. They are going to leave the cascade. We will continue with C4B, which is binding pathogen. Now, again, the same time, this C1 will activate or cleavage C1 into C2A and C2B. So, usually, A is leaving cascade, we are remaining with B, but there is exception only for this C2A, where this C2A are going to be remain in the cascade. Now, what will be the next? C3 convertase formation means this C4B and C2A, they are going to form what we call C3 convertase. Now, C3 convertase, they are going to convert C3 convertase, they're going to convert C3 into C3A and C3B. This one, it is inflammatory. They're going to leave the cascade. We're going to remain with C3B, which acts as opsonization, as we have seen the importance of the these pathways. So, after having this C3B together with C4B and C2A, they are going to form what we call C5 convertase. C4B, C2A, C3B, all of these three, they call it C5 convertase. Now finally is termination, where this C4A are going to leave the cascade, will remain with C5B. C5B will recruit C6, 7, 8, 9, together of all of them, they will form what we call membrane attack complex, which will rise the pathogens. Now our pathogen is now died. They are no longer causing the harm. So that's all about the classical pathways. Take time and review. Let me talk about the mannose binding lecithin pathway. So this is another pathways in the complement system. But this pathway, now we don't have antigen antibody complex. What do we have? We have bacteria. We are having the bacteria with mannose in their cell wall. In the cell wall of this bacteria, there is mannose. Now what will happen? There is what we call mannose binding lecithin. This is in our body. They are going to be activated because of this pathogen which have mannose in their cell wall. So what they will do, this lecithin complement pathway, they are very, very similar to that one of the classical pathway, except only one step is missing. Means bypassing C1, means here there is no cascade 1 or protein C1 which is going to be activated. This one is now jumped. Now this mannose binding lecithin is able to automatically activate C4 and C2 to form C4B and C2B, where now C4A and C2A, they are going to leave the cascade. We are going to remain with C4B and C2B. Those two proteins together, they will form what you call C3 convertase. This is the enzyme which will convert C3 into C3A and C3B. These two proteins, this one will leave cascade, we will remain with this C3B. C3B together with this C4B and C2B, all of these three, they are going to form enzyme called C5 convertase. This enzyme, what is going to do? They are going to, it is C5 convertase, means they are going to convert C5 or complement 5 protein into C5A and C5B. This one will leave the cascade. Usually A are leaving the cascade. We are remaining with C5B, which will recruit 6, 7, 8, 9, which will form what you call MAC, membrane attack complex. Now by here we are going to destroy, to make pores in this bacteria. Now automatically this bacteria, they are going to be died. Now this bacteria is unable to cause our body harm. So let we have a mnemonic on this. Mnemonic, it is protein 4, 2, 3, 5. 5 will recruit 6, 7, 8, 9. So count with me. 4, 2, 3, 6, 3, 5, 6, 7, 8, 9. So what this means? Means the pathogen with mannose in their cell membrane will come. Now there will be activation of mannon binding lecithin in our body. This will cause complement 4 to be activated and complement 2 to be activated into 2 C4B, C2B. There's C2B will form what you call C3 convertase. This is the enzyme which will activate C3. Means they're going to be formation of C3B and C3A, C3B are going to be remained in the cascade. So this C3B together with this one of this, which is C2B and C4B, all of these three, they're going to form what you call C5 convertase. This is the enzyme which is going to form, which is going to convert C5 into C5A and C5B. Now this C5B will recruit, this C5B will recruit 6, 7, 8, 9, which will form what you call MAC. This MAC will destroy the enzyme. I hope this is clear, because it is very, very similar to classic pathway. Only difference is the classical pathway, there is antigen antibody complex, and now they activate C1, but here there is no antigen antibody complex, but you have mannon, or there is mannose in the cell membrane of this pathogen, which will now activate C4 and C2 cascade complement proteins. So you should remember that C3B, it is for opsonization, as you have seen that in the importance of the complement system. So let we have look on the tautology of this. The steps are like this. There is recognition, means there is mannon binding lecithin, which bind mannose or rate the sugar on the pathogen surface. This is activation. Now after activation, there are going to be activation of C4 into C4A. This one is inflammatory, they will leave cascade, will remain with C4B, which bind the pathogens. Now this mannon binding lecithin also will activate C2 into C2A and C2B. We now always usually A is leaving the cascade, we are going to remain with C2B. Now together with this one, there's two C4B and C2B activated form, they will form what you call C3 convertase. This is the enzyme which is going to convert C3, which is going to activate C3. How? C3 are going to be activated in which ways? Means by help of this C3 convertase enzyme, they're going to convert C3 into C3A. This one will leave the cascade. We're going to remain with C3B, which is going to continue in the cascade, which is usually opsonization. The next means C3 is activated into C3B. Together with this C3B and the previous one, C4B and C2B, they are going to form what we call C5 convertase. This is enzyme composed by C4B, C2A, C3B, which is usually going to convert, C5 into activated, which activation into C5A and C5B. Usually A they leave cascade, we are going to remain with C5B. So this C5B usually they recruit 6, 7, 8, 9. Now this they form what you call membrane attack complex. This one will go and now destroy pathogen. Now MAC they rise, pathogen they destroy the pathogen. Now pathogen are no longer causing the problem to our body. So this is all about mannose binding lecithin pathway or lecithin pathway. So let we have look on alternative pathway. So alternative pathway, usually it is a little bit complicated comparing to others because all of them were similar. Usually in the classical pathway, the antigen antibody complex which activate C1. In the Reshtin pathway, we are having mannose on the surface of the pathogen, which will form the which will activate mannon-Reshtin binding, which will activate C4. C4 means complement 4. It is a first protein to be activated in Reshtin pathway. So here in alternative pathway, the steps as we are going to look at it after the finishing explanation on the diagram. So usually in this alternative pathway, we don't have antigen antibody complex, we don't have pathogen with mannose. What do we have? We have what you call endotoxins. Endotoxins means what? Means if it is bacteria, is lipopolysaccharides. Means those gram-negative bacteria, they have lipopolysaccharides on their cell membrane of it. They will come and now they will activate what you call alternative complement pathway. So not only bacteria, can be yeast or virus which can secrete the toxins. Now here they will going to activate complement 3, C3 protein. Together with factor B and activated factor D, we're going to have C3B, where C3A is leaving the cascade. This B is going to form BB. This BB, this is also protein. Together with, means by having activated B, which is BB, and activated C, which is C3B, you're going to form what you call C3 convertase. Usually C3 convertase, they convert C3 protein into C3B and C3A. Always A will leave the cascade, we are going to remain with B. So this B, remember, we are going to have C3B in the same, twice in this alternative complement pathway. Means here, means after activation of C3, they form C3B and this factor B form BB. All of these two form C5 convertase, which will convert again. Don't be confused. We have C3 two times. Again, C3 will be going to be converted into C3A and C3B. A always leave the cascade. Now we remain with this C3B. This C3 which remain in this cascade, together with this one and this, they are three. They form what you call C5 convertase. This C5 convertase, they convert C3 into C5A and C5B. Usually this protein, they leave cascade. They are going to remain with C5B. C5B, it will recruit 6, 7, 8, 9. All of them, they reform what you call MAC, membrane attack complex, which form pollens in this bacteria. Boom, boom, destroy this bacteria. Now this bacteria is no longer causing harm to our body. This is still alternative complement pathways. So I have the mnemonic also here. There is 3, B, 3, 5, 6, 7, 8, 9. So means here they are going to have the endotoxins, either lipopolysaccharides, fungi, or virus, which will activate C3B. Means in the presence of factor B and factor D, which is activated, we are going to form C3B and BB, which this together the two, they're going to form what you call C3 convertase. Now C3 convertase, they are going to convert C3 into C3B, Now together all of this, or means C3B, BB, C3B, they are going to form what you call C5 convertase. Now C5 convertase will convert C5 into C5A and C5B. Now this C5A leave the cascade. C5B, they are going to recreate 6, 7, 8, 9. Now they form what you call MAC, membrane attack complex. Now, boom, destroy bacteria. Let you have a look on the tautology of it. The step by step means there is spontaneous activation. Means C3 undergoes spontaneous hydrolysis or activation, where they are going to be C3B activated. In the presence of factor B, they are going to bind and now form what you call form what you call BB. Means they're going to be, this factor B will be BB. Together with this one and this, they will form what you call C3B and BB, which is going to be C3 convertase. This is the enzyme which are going to convert. They're going to convert C3 again, C3 into C3A and C3B. Those are proteins. This C3A will leave the cascade, but C3B will remain in the cascade, where this C3B together with this one, C3B again and BB, they will form what we call C5 convertase. Means what is this? C3B, BB, C3B, all of this, they form what we call C5 convertase. So now, you know, this C5 convertase is going to convert or to activate C5 into C5A and C5B. This C5A, we're going to leave the cascade. We're going to remain with C5B. This C5B is the proteins which remain in the cascade, where it recruits 6, 7, 8, 9, which we are going to form what you call mark. This mark, they're going to rise pathogen. Now pathogen is now died. It is no longer causing the disease. So this is all about alternative pathways. So, like in summary, these pathways, as you are seeing here, all of them, they're going to be activated according to the nature of the pathogen. If the pathogen come and form antigen antibody complex, which cascade is going to be activated? Yes, it is classical pathway, because you are having antigen antibody complex. In lectin pathway, means when this lectin pathway is going to be activated, when the pathogen, they have mannose in their surface, in their cell wall. Now, which cascade now? Lectin pathway. Now, suppose that there is endotoxin like lipopolysaccharides. Lipopolysaccharides, if it's there, which cascade is going to be activated, or pathway is going to be activated? Very good, alternative pathway. So, this alternative pathway means, remember, in all of them, we have C3 convertase, but they are different. Like in this one, classical pathway, remember, it is C4, C4B, C2A, and this one is C3 convertase. In this mannose, remember, it is the same. It is C4B and C2A, which is C3 convertase, and then this one alternative pathway. Remember, it is C3B, BB, and C3B again. This is the C3 convertase. Those are the enzymes. Now C5 convertase, it is very, very easy. It's just only to add C3B. So now, after formation of this C5 convertase, we are going to form what we call membrane attack complex. So here it is a summary which is summarizing everything. Means you should understand. Now, in classical pathway, lectin pathway, alternative pathways, what is initiator? Problem number one, which first complement protein to be activated? What are the components of this C3 convertase? What are components of C5 convertase? What complement level in the serum means, and also immunity. So this table, it is summarizing everything. So you should pause and review. Classical pathways, we are having antigen antibody complex. In the lectin pathway, there is mannose, binding residue of the bacteria cell wall. In these alternative pathways, we are having endotoxins or cancer cells. Which first complement to be activated? Remember, in classical pathways, C1. In lectin pathway, C4. In alternative pathways, is C3B. Very good. Now, this enzyme here, we are having C3 convertase, means we are having C1, C4B, and C2A. Now, in lectin pathways, there is a C4B and C2A. And in alternative pathway, there is a C3B and BB. C5 convertase, this is C1, but usually this C1 is not there. It is in this C5 convertase. The C5 convertase, we are having C4B, C2A, and C3B. This is C5 convertase. In the lectin pathway, it is C4B and C2A and C3B, which is going to be C5 convertase. In alternative pathways, we are having C3B, BB, and C3B, which is going to form what we call C5 convertase. Remember, now the complement level in serum, because we are having all nine cascade protein, means if we are going to complement level in the serum, we are having all of them. Okay. Now in lecithin, C1 is means when you have the pathology, all of them are going to be low because all of them are in the serum. Now in the lecithin pathway, because C1 is not there in the pathology related with this lecithin pathway, C1 is normal because usually is not usually in the pathway, but others they are going to be low. Here in alternative pathways, C1 and C4 and C2 is normal because is not in the alternative pathway. Remember, now this one classical pathway is acquired while we have antigen antibody complex. This one is innate. Innate means that you're born with, because here there is no exposure of the antigen. Usually you're born with these two proteins found here. So I'm going to finish on this slide regarding to the pathology. Means that those complement system, they are helping us in the preventing the pathogens. Means once you have the efficiency of the one of the nine protein, you're going to end up in pathology, disease. For example, C1, C2, C3, C4. This one, they're going to, once they are deficiency, you're going to have systemic lupus erythematosus. There is glomerulonephritis, pyogenic infection. All of these infection, they are caused by early stage of this complement proteins. Very good. Means because we are having 1, 2, 3, 4, means classical pathway is going to be defective because there is C3, and remember the C3, it is like in the between, means C3 is found in both pathways, because this one also is deficiency. You have common, means all of the pathways are deficiency, are now affected. So there is factor D. Remember factor D in the alternative pathways, Neisseria gonorrhea or Neisseria meningitis, those diseases are going to suffer. There is pyogenic infection also because of deficiency of those properdin and this factor D. Membrane attack complex, usually from complement 5, 6, 7, 8, 9. All of this deficiency means all of the pathways are going to be affected. We will have what we call disseminated Neisseria infection. If we are lacking C1 esterase inhibitor, means remember C1 inhibitor are in classical pathways. Means this is C1 esterase. Once there is no inhibition of this enzyme, there is no inhibition, you're going to have high production of C1, means you're going to have overreactive of this classical complement system, because this enzyme inhibitor of it, or means regulatory of this enzyme is not there. So continuing by this pathology, means deficiency of this C1 esterase inhibitor, they're going to be overreactive of classical pathways. These classical pathways, they're going to be working like crazy. We will have what you call hereditary angioneurotic edema. So lastly, we are going to have what you call decay accelerating factor and CD59. This one, DAF or decay accelerating factor, it is there to make the deregulated C3 convertase. Once you have the problem in C3 convertase, they're going to be problem of PNH, paroxysmal nocturia hemoglobinuria. Also, if there is no CD59, they're going to be increased cell lysis. Now, this protein is there to maintain the cell membrane integrity of red blood cells. So that's all about the complement system. Pause and review. I hope this complement system now is like a piece of cake. So stay tuned, and then don't remember to subscribe, like and share. Thank you so much.